Welcome back to my channel. This is the second video of numerical solution series of chapter 1 of ICSE class 10 physics. Numerical number 7. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw a diagram to show the application of forces and calculate the moment of force applied. Okay, so here it is stated that diameter of the wheel is 5 meter, sorry 0.5 meter, and it is rotated anti-clockwise by the application of two forces. So let us say this is point A and this is point B. Now to rotate this steering wheel in anti-clockwise direction, we must apply the force at point A towards left and the force at point B towards right. You can also draw the diagram in this particular manner. Take point A over here and point B here. This is the diameter 0.5 meter, and to rotate the wheel anti-clockwise we can apply the force at point A downward and force at point B in upward direction. Right now for the explanation purpose I am taking the first diagram. The forces are of value 5 Newton. So let's say the force at point A is F1 and the force at point B is F2. Each one is having the same magnitude 5 Newton. So these two forces are equal in magnitude, opposite to each other, acting at different points. So they generate what? Couple. And we know that moment of couple is magnitude of any one force into distance between the two forces. That is 5 into distance between the two forces is what? 0.5. So this is 2.5 Newton meter, and the direction is already stated in the question, anti-clockwise. Numerical number 8. A uniform meter rule is pivoted at the midpoint. A weight of 50 GF is suspended at one end of it. Where should a weight of 100 GF be suspended to keep the rule horizontal? Let us first understand what is the meaning of uniform meter rule. Pay a very close attention to this because this is very important point of torque numericals. Uniform meter rule. In most of the numericals you will find this phrase. So the meaning of uniform meter rule means mass is equally distributed. Okay, mass is equally distributed. See, uniform meter rules, it's a meter rule, so the length of the meter rule is of course 1 meter or 100 centimeter. And let's assume that mass of this particular meter rule is 100 gram. So the meaning of uniform meter rule or equal mass distribution is that per centimeter, if I take just 1 centimeter length of the meter rule, the mass will be how much? 1 gram. If I take a meter rule of length 2 centimeter, then the mass will be 2 gram. So per centimeter, mass is 1 gram. Okay, so the total length is 100 centimeter. So the total mass becomes 100 gram. This is the meaning of mass is equally distributed. Let's take one more example. Suppose if the mass of the meter rule is 200 gram. So the mass per centimeter will be how much? 2 gram. Okay, so if you take 1 centimeter length meter scale and measure its mass, it becomes 2 gram. This is the meaning of mass is equally distributed. And since mass is equally distributed, the center of gravity of such meter rule is always at 50 centimeter mark. Okay, since center of gravity is at 50 centimeter mark, that is the midpoint of the meter rule, we can also say that mass of meter rule is concentrated at which point? At 50 centimeter. So now whenever you come across such word that there is a uniform meter rule, the mass of meter rule is at 50 centimeter. Now here in the question it is stated that uniform meter rule is pivoted at the midpoint. So the mid, it is pivoted at midpoint, meaning at 50 centimeter. So fulcrum is at 50 centimeter. See, since it is uniform meter rule, its weight will also be at which point? 50 centimeter. And if you keep the fulcrum at 50 centimeter, the meter rule is balanced, or we can say meter rule is in horizontal situation, because weight is at 50 centimeter and the fulcrum also exerts the force at the same location in upward direction. Okay, so the weight of the meter rule and the force of the fulcrum balance each other. So the meter rule remains horizontal. Now it is stated that a weight of 50 GF is suspended at one end. Which end? 0 centimeter or 100 centimeter? That is up to you. Okay, if you want to take the 50 GF weight at 0 centimeter mark, then also fine. And if you want to take 50 GF at 100 centimeter, then also it is absolutely fine. Right now I am taking 50 GF weight at 0 centimeter mark. Now because of 50 GF at 0 centimeter, the meter rule will tilt in anti-clockwise direction. So to balance the meter rule, 100 GF must be suspended on the right hand side of the fulcrum. And at what location it must be suspended, that is what we need to find out. Okay, so we need to find this distance, let's say D2. Let's say 50 GF is F1, its distance from 50 centimeter is D1, and 100 GF is F2. So since the meter rule is balanced, we will have to use the principle of moment. So we have to write the statement first. According to the principle of moments. Now whenever you come across such numericals where principle of moment is to be applied, make sure that this particular statement is must. It is mandatory to start the numerical with this particular statement only. So according to the principle of moments, total anti-clockwise torque or moment is equal to total clockwise torque. That is F1 D1, right? Force F1 50 GF creates anti-clockwise moment, and 100 GF F2 creates clockwise moment. So F1 D1 is equal to F2 D2. F1 is 50, D1 is also 50, is equal to F2 100 into D2. So D2 is 25 centimeter. Now we know that this distance is always from the pivot point. Okay, so you can leave the answer here as it is, that D2 is 25 centimeter, or you can say that 100 GF must be suspended at 75 centimeter mark. Okay, because 25 centimeter is from where? It is from the fulcrum or the pivot point, and here in this case the pivot point is at 50 centimeter. So 25 centimeter from 50 is nothing but 75 centimeter mark. So your answer can be D2 is equal to 25 centimeter, or 100 GF must be suspended at 75 centimeter mark. So if you want to write answer in terms of 75, do not forget to use this word mark. Ninth numerical. A uniform meter rule balance is horizontally on a knife edge placed at 58 centimeter mark when a weight of 20 GF is suspended from one end. Now see, once again there is a uniform meter rule. Since it is a uniform meter rule, just by reading that, we can say that the mass of meter rule is at 50 centimeter. So this is the weight, this is the point where weight of the meter rule is. So just by reading this phrase, that a uniform meter rule, we can draw this much diagram. Now if we read further, it states that it is balanced horizontally on a knife edge placed at 58 centimeter mark. So the knife edge or the fulcrum or the pivot point is at which point? It is at 58 centimeter mark. Okay, so now after drawing this much diagram, it is very clear that because of weight of the meter rule, this meter rule tilts in anti-clockwise direction. To balance the meter rule, we must suspend 20 GF weight from one end. So this 20 GF must generate clockwise torque, and for that it must be suspended on the right hand side of the fulcrum, and the end of the meter rule on the right hand side is nothing but 100 centimeter mark. I hope this is very clear to you. If not, you can rewind the video and watch this explanation again. So now the question is, draw a diagram of the arrangement. So this is the diagram. Of course, we can mark the arrow for clockwise. What is the weight of the rule? So for that we need to use principle of moments. So the mandatory statement, according to the principle of moments, total anti-clockwise torque is equal to clockwise torque. Anti-clockwise torque is due to weight of the meter rule. Distance of weight of meter rule from fulcrum is 8 centimeter. Clockwise torque is due to 20 GF, and its distance from the fulcrum is 42 centimeter. So weight is 20 into 42 upon 8. 4 5s are 20, 4 2s are 8, 21, and this is 105 gram force. So weight of the meter roll is 105 gram force. 10th numerical. The diagram alongside shows a uniform bar suspended at the middle point O. A weight of 40 GF is placed at a distance 40 centimeter to the left of the point O. How can you balance the bar with a weight of 80 GF? Now since 40 GF is on the left side of the fulcrum, this 40 GF generates anti-clockwise torque. So to balance it, there must be equal amount of clockwise torque, and for that 80 GF must be suspended on the right hand side. So according to the principle of moments, total anti-clockwise torque is equal to clockwise torque. Anti-clockwise torque is due to 40 GF. Distance of that from the fulcrum is 40 centimeter, is equal to clockwise torque is due to 80 GF, and distance of that we need to find out. So distance is 20 centimeter, and this distance is of course from where? From the center point O. 11th, figure shows a uniform meter rule placed on a fulcrum at its midpoint and having a weight 40 GF at 10 centimeter mark and a weight of 20 GF at 90 centimeter mark. Is the meter rule in equilibrium? If not, how will the rule turn? Now see, we need to find out, is the meter rule in equilibrium? And the subsequent question is, if not, how will the rule turn? So common sense says that if that question is asked, meaning the meter rule is not in equilibrium. Okay, so we need to prove that that meter rule is not in equilibrium. So for that, let us find out total anti-clockwise torque first. Anti-clockwise torque is due to 40 GF at 40 GF at 10 centimeter mark. So distance of that from the fulcrum is 40 centimeter. So 40 into 40, 1600 Newton centimeter. And we already mentioned the direction here, anti-clockwise. Clockwise torque is due to 20 GF at 90 centimeter mark. So the distance of 20 GF from the fulcrum is again how much? 40 centimeter. So force is 20 GF, distance is 40, 800. Sorry, in the first case the unit will be gram force centimeter. So clockwise torque is 800 gram force centimeter. Anti-clockwise torque is 1600, clockwise torque is 800. So we can say that meter rule is not in equilibrium. If not, how will the rule turn? So it will turn anti-clockwise. It will turn anti-clockwise because anti-clockwise moment is more than clockwise moment. How can the rule be brought in equilibrium? By using an additional weight of 40 GF. Now, since clockwise moment is less than anti-clockwise moment, this 40 GF must be used to generate some additional clockwise moment. Let us first find out net moment. Net moment is anti-clockwise torque plus clockwise torque. Anti-clockwise is 1600, that is positive, and clockwise is 800, that is negative. Net moment becomes 800 gram force centimeter anti-clockwise. Okay, so our additional weight 40 GF must generate 800 gram force centimeter clockwise moment. So we can say that clockwise moment or clockwise torque is 800 gram force centimeter, and this torque is because of 40 GF distance we want to find out. So D is equal to 20 centimeter from the point O, or we can say it must be suspended at 70 centimeter mark. 12th numerical. When a boy weighing 20 kgf sits at one end of a 4-meter long seesaw, it gets depressed at this end. How can it be brought to the horizontal position by a man weighing 40 kgf? So let us first draw a seesaw. The length of the seesaw is 4 meter, 0, and this is 4 meter. And of course, the fulcrum for the seesaw must be at the middle point. So this is 2 meter, and here is a fulcrum. A boy weighing 20 kgf sits at one end. So let us say boy is sitting at 0 meter mark. The weight of the boy is 20 kgf. And according to this diagram, the boy will generate anti-clockwise moment. So to balance the seesaw or to make it horizontal, man weighing 40 kgf must be on the right hand side of the seesaw, and he will create clockwise moment. So that is weight of the man is 40 kgf. So we can say again, according to the principle of moments, total anti-clockwise torque is equal to clockwise torque 20 kgf into distance of that from the fulcrum is 2 meter is equal to 40 into D. So D is equal to 1 meter. Thank you.